Howdy. So I have a 99 Ram 59 Cummins ECU here to go through, and it was sent in because the customer was working on his AC circuit, said it kept blowing 10 amp fuse, tried to test the voltage, hit the prongs of the fluke. I guess he shorted them, and the pickup cut out and would not start. Fuel system wasn't getting power. Jumped it with 12 volt and it kicked on. Code thrown 1689. So, what was 1689? That can't remember what 1689 is. I'm pretty sure it's for the injector pump. So let's plug in here and turn it on. Okay. So now what we should see here is we should see our white wait to start light come on. We should see our fuel pump relay LED come on. But I think something's wrong with that LED. I think I messed it up. Different job. So actually, I'm going to put this lamp here, this test light, until I can fix it. I don't feel like fixing it right now, but I'm going to put that lamp there, and that is for the relay control for the injection pump. All right, and also going to see the in tank pump come on, and that should cut off, and that's this lamp here. So you'll have two lamps and a white wait to start. Okay, and there we see the wait to start come on, cut off. We saw the um, in tank pump come on and cut off, and we see our relay powering the injector pump. Okay, so that is all good news. Now I'm going to turn on the autel here, and we are just going to do some quick checks with it. Just I want to go through, see if there's any weird codes. I want to see if the live data is responding like I'm used to seeing. And after that, I'll go ahead and open it up and take a look. So we can ignore this 1693. Don't care too much about that because we don't have the PCM hooked up. Water and fuel, I have that sensor here, but it's very delicate and I don't have it set right, so that's okay to see that. The app signal is too low. Probably shouldn't be seeing that one. Any of these too low ones probably should not be seeing. No communication between the ECM and injector pump. That's normal because I have no injector pump hooked up. And no CCD message from the PCM, which is also normal because I do not have a PCM hooked up. But while we are here, let's go ahead and hook up an injector pump. Since that is the code that they were getting, I just want to make sure. Now, I'm not going to run the injection pump or anything. I'm just going to hook in a module to make sure it's communicating. Okay. And I don't really care about it syncing or anything like that for this particular case just yet. I just want to make sure it's getting powered and communicating. Okay. And we're going to check that relay again. It's still good. Okay. So now when I erase the codes and I read again, we should see communication with the injector pump. Oh, I have this here. I guess you guys can't see it. That lamp is just for the solenoid. It's not important. Okay, so we did get rid of got rid of a lot of error codes actually. So those error codes that we saw possibly could have been from uh, before I connected my equipment. They could have actually been stored codes. I can't remember if this system will tell you if it's active or stored. They might only give you codes and not tell you if it's actually current or history code, because the low voltage ones are very weird because I'm looking at my tester here and I know the ranges of where the pots are, pretty much set at. And I know they're not low. Only the water and fuel is a weird one. The other ones they're pretty good there. So that could have been external issues that just happened to still be there. Uh, so 1698, is that the code that? No, 1689 injector pump. Yeah. Okay. Well, so far it doesn't look like there's too much wrong. Let's check the live data here. It might be kind of hard to follow along with me because you're kind of taking my word on what's good and what's bad, and I do these every single day, so and my tester is kind of weird, so I'm just familiar with it. Um, so if I say something's normal, even though it looks weird, you just have to take my word for it. Now I want to see if the intake air temperature will adjust, and it is adjusting, so that is good. The water and fuel, let me see if it adjusts. It does adjust. Okay, let's keep it lower. Now the apps one, a lot of times this one doesn't adjust in the live data for the voltage for some reason. I'm not sure why. I think it's a problem with Altel because some of them won't adjust like they're supposed to. Some of them do. But usually you can see the pedal position changing. This one right here. Usually this will change, which is not changing right now. So that's kind of weird. All right. Let's switch the idle select and see if that changes anything. Yeah, it's not doing anything. So that's a little bit weird, but for some reason the apps is kind of odd on this. Let me check the map sensor, or in this case it's labeled as boost, and that appears to be adjusting, which is okay. Okay, I'm not going to give it any kind of RPM right now. Injector pump engine speed, I'm not going to rotate that. Let's check the coolant. I just want to make sure these are changing, because if they don't change, then it leads me for another problem of what's inside. Yeah, and see, this has a nice temperature what it thinks the fuel is. I think that's just kind of its standard range. Now, if the injection pump was not hooked up, this would not be reading this. You see how these two are kind of identical, the ECM and the injection pump? If I was to unhook the injection pump, then this would not read at 1376. It would read probably more around 10. Okay, so everything looks normal to tell you the truth. Now, this doesn't mean that the ECU is okay. All right, this is just basic stuff that I'm going over. There's still more that can be wrong, and there's stuff that won't show up with this. That's why, I'm still going to open it up. I'm still going to inspect it, and I'm still going to do component level testing. And I'll also make some basic repairs that I do for every single one of these, just because of their age. They suffer uh, certain problems related with age, and anytime they come in, I always fix those regardless if there's nothing else wrong. But This is just the beginning of the test, but nothing looks too weird. Nothing's looking too weird, tell you the truth. Let's see. Now we got some new codes here, which is good. So by me working the throttle position sensor, we do see that it did activate a bunch of codes because I turned it all the way low, I turned it all the way high, and it did come up. And then I was turning the idle validation or the idle select, whatever you want to call it, on and off, fiddling with that. So it's good to see that those codes come in. That means that even though the live data wasn't showing me the right data, it was picking up the data like it's supposed to. Okay, I don't need to do no active test right now. Let's go ahead and shut this off and open the ECU up, and first we'll do a visual inspection, and then we will do component level testing, just of some of the basic components. Okay, let me move this out the way. All right, so we've got the ECU open here. First thing we're going to do is do a visual inspection. Now this is the logic side. I see something weird looking there, like a broken capacitor or some dirt or something. I'm gonna look through the microscope because my eyes don't work as good as they used to. Okay. Well, it's just some bad. It is, yeah, it's a busted capacitor, but that would not be causing our issue. That looks like it's just slightly off, or maybe I accidentally done it. I don't know. It does look weird, but I opened it from the other side, so I'm not sure how that happened. But I will fix that. Don't really see anything else. And that looks good. So on the logic side, there will be some stuff that I have to fix, but I don't see anything that was be causing any concern of the customer. So now we're going to check the power side and the connector side. Um, we did have power and all that, so let me move that out the way. Okay, so there's our power coming in. Oh, there, look at that. We have something there. That is a burnout trace. And what is this trace for? I do not know. I don't remember, but it's very big, so it's got to be for something important. It looks like a 5 volt or something. I don't think it's this guy. Let's see if we have any other problem. Man, I can't believe something that bad didn't show any issues because it's completely burned open with the tester. I really don't know what this line is. Or maybe it's just making just enough connection. I'm trying to pull off the jelly coating without messing it up. So it does look like it's still slightly connected because I wiggled it and both sides wiggle. Okay, let's do this. I'm hoping to not lift it away. I want to see if it's completely burned in half or if it was. It looks like it's hanging on by just a thread. I can't get the jelly stuff away enough to see. I hate this stuff. So damn annoying to work with. Alright, so let me just stop goofing off and now just pull it up. Oh, there we go. So it was completely severed, whatever it is. So let's pull away a little bit more of this. Okay, and let's just cut it right about here. Get rid of it. I'm gonna do the same thing over here. All right, and we're gonna cut it right there just to get rid of it. Now let's try to find out what that goes to, because I'm not too sure. I'm not sure if it's a ground or if it's a power. It's definitely one of them because it's very beefy. And I don't know if it's an output because it doesn't look like it's going right to the connector. It could be the 5 volt rail, because it is coming over here to these capacitors. But if that was bad, I can't believe there wasn't more stuff showing as bad. And man, all the fuel stuff was working. That is something. So let's see if they're connected. Yeah, they're not. I was gonna say maybe it was connected somewhere else as well as here. All right, so I'm gonna just clip onto this capacitor here. I'm gonna check the power spots first. Okay, I think it's going to these capacitors from this side. No, it wasn't. It's coming to this resistor right here. And I'm not sure where it's going from there. Is it ground? It is, so it is a ground. So maybe the low voltage codes were from this, because if that is a ground that goes to half of the board, we would be, losing a lot of stuff. So I'm just trying to get some of this stuff out of here so I can see better. All right, so this goes, if it's ground, let's see if it goes to these grounds too. It does. Okay, but if we come to this side, let's see these capacitors here, and let's see if it goes to this ground. No? So I'm curious where it goes from here, because I can't really see in there, but, oh, sorry, it doesn't go there. It doesn't connect to this ground over here. See if it goes to some kind of output. It's pretty rare that ground would be carried just through a fat little trace like this. I mean, it is fat, but it's still, that's not typically how a ground is carried to an entire side of the board. So I'm not sure where this ground is going. So this half is all connected to ground, and this one is not. This one is going out to something. So maybe, oh, that's what it's coming out of the ECU. So let's see what pin this is. 1, 2, 3, 4. 1, 2, 3, 4. So that is pin 44. No, 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 no. That is actually pin 4. What is pin 4? I don't remember, but let's see if it's on the tester here, because I do have them named, and there is no E4 on here. You know what? I bet you it is a sensor ground. I bet you that's what it is. I bet you that's a sensor ground coming from the ground plane going to the output. because sensor grounds are about the only thing that I did not put on my tester. And then that would make sense to why everything is working on my tester and not the ECU, because I tie all the grounds together in my tester simulator. I don't use the signal grounds because I was saving ports on the output, because I use a D sub connector. See, like this D sub connector, and I had to reserve spots because I filled them up. So I cut out all the sensor grounds and just internally connected it to the ground in here. And typically the ECU is built the same way. All the sensor grounds are connected together. And this one would be if it wasn't burn open. But let's just verify that by checking wiring diagram. Okay. So let me pull it up here for you guys to see. Okay. Is that open? Okay. Well, let me zoom in. All this crap. So let's go to wiring. And from here, we're going to go to connectors. If this has it. I can't remember where the connector is. Where did it go? See, the other one is nice. You can click it. Oh, here they are. You can just click it and it will have them labeled out good for you. This one doesn't. So this one, we want to find the ECU, engine control module, not the powertrain. We need the engine control module. So it's probably going to be an E. Where are we at? We're at J. Now we are at J still. Here we go. Engine control module. Yep, there we go. Number 4, sensor ground. Boom. All right, so this will definitely cause problems. Let's just for fun see what it's a ground for, which sensors, because different sensors use different grounds. Okay, so here we go with the fuel ignition system, and we want to check for ECU pin 4. So we just have to keep going till we can find, this is still gas. What am I looking at gas for? Let me keep going down. Find the diesel. Okay, we should be getting to it. Yep. Now we want to find sensor ground 4. I have not found it yet. There it is. It is for the camshaft position sensor. So yeah, if you don't have the sensor ground for that, you will definitely not be able to start your truck. All right, so now that we have found that that is a sensor ground, so that's a pretty beefy sensor ground just for the camshaft, but at least we got it figured out. So pretty easy fix to do there. Let me go ahead and I'm just going to leave that just like that. Even this little weird area, I guess I can put on the big microscope, can see a little bit better. I'm just going to bridge that with some jumper wire. If I can get in focus. I'm fairly certain it's safe to call this one resolved. All we have to do is fix this connection here. I'm just going to use a basic jumper wire, flux it and solder it on. And then I'm also, just as a courtesy, going to do my other normal stuff I talked about, which includes the all the capacitors. I'll change them. And I'm gonna go around and I'm gonna check the tantalum capacitors. I don't usually change those unless they're bad. And there's a few resistors that I like to check, and also there's some logic stuff that I want to do um, to get this thing 100% and hopefully not have any additional problems in the future. But I don't think I'm going to bore you guys with all of that because changing capacitors is pretty boring. And this is probably pretty boring too. But while I got you here, I guess we can go ahead and finish fixing the main issue here. And I'm gonna tin this first. I like to always tin this stuff. Now I was debating on if I should cut that mangled piece off, but I guess we'll just leave it. Can put a little bit more flux. I know it's a lot, but it makes things a lot easier. Now, since I'm going to replace the capacitors, I'm just going to cut one of the legs off of the capacitors that I'm going to use because I have to cut them anyway. So you see, I'm going to take it. This is how I do the capacitors. Very simple. I'm going to take it. I'm going to fold it this way. I'm going to fold it that way, okay? And that's just the way that it sits in there because they have the axial capacitors, but they are used as SMD components. And then I'm going to take the lead here. And since I got to trim it, we're going to take it and use that as our jumper. Let's take the smaller one. And then I'm going to use that capacitor here in a little bit. Now, this is the only problem with tinning is that, it won't sit good. So I wish I had my bigger tip on my other iron, but changed it to the smaller one because it would have been nice to heat the whole thing up evenly. But that's not too bad. And I'm going to add even more solder because stuff like this, I really like to just glob it on there and just make it very heavy duty, you know. I'm actually trying to move it a little bit. It kind of shifted around on me. Wasn't too happy with the way it shifted. So I don't, it doesn't matter, like this little bend here, but I don't like it. And this is just me being picky. So I want to push it back just a little bit. Okay, yeah, that looks better. Now it don't look weird. Not that anybody will see it anyway, but. So we're going to clean that off. Now, I guess I could put solder mask there, but I think I'm just going to lay this conformal coating over top of it. And I will let that dry while I do the capacitors. And then once the capacitors are done, and I check a few of the resistors that I like to check and the tantalums, and fix the logic stuff, then this guy will be all done and heading back to the customer. Man, that turned out to be an easy one. I like them like that. I love to see an exact fault that I can just instantly see, fix it, and know that it's done properly. That's always the best, rather than having to dig and dig through the circuitry and try to locate random, miscellaneous logic faults and stuff like that. They take a long time and it's just a pain. Just a pain. So that was very nice and relaxing for me. Anyway, I am going to end this video here because, like I said, capacitor replacing is kind of boring. And I hope you enjoyed the video.